A couple of months ago, I made a series of videos on deferred rendering in GameMaker, and I cited one of the advantages of deferred rendering to be that if you had a very complicated scene with a lot of complicated objects and a lot of large objects and a lot of objects that are off in the background being occluded by objects that are in the foreground, and more especially if you have a very complicated fragment shader, which has to do things like process a lot of lights in the scene all at the same time, then you're inevitably going to end up in situations where you draw one thing, it runs the complicated fragment shader on it to resolve all the pixels, and then it immediately gets overdrawn by something else that's in front of it, and lo and behold, you've wasted some amount of milliseconds rendering an object that didn't actually end up on screen. And deferred rendering, of course, gets around that by resolving all the stuff in the 3D scene with a very simple shader, writing some basic information to multiple frame buffers, and then once you're done with that, you're just going to run the complicated lighting calculations on the stuff that's actually on the screen, and you don't have to waste time doing stuff like drawing a hill that's off in the background that's being hidden by this castle. And in the comments of one of those videos, someone brought up essentially the fact that there are other ways to approach this problem. Deferred and forward are, I'm going to say, easily the most popular, but other strategies do exist. And the one that we're interested in today is the depth prepass. So what if you wanted to, instead of doing a deferred render where you have to juggle like multiple frame buffers with color and normal and position information and whatever, what if you instead drew the scene once, you save the depth information, and nothing but the depth information, no color or lighting or anything like that, and then you drew the scene again, but only paid attention to the pixels that are at the front of the depth buffer. That is the basis of the depth prepass, and it's not too difficult to implement. So prerequisites for this video, there's actually not a lot of specific subjects that you're specifically going to need knowledge of to do this. I'm not really going to talk about deferred rendering besides what I already said. Aside from general 3D knowledge, like how vertex buffers work, how shaders work, how stuff like depth works, there's not really any specific set of videos that I've made in the past that I can point to and say that you're going to need this, but at the same time, this isn't really a beginner level thing, although all the same, I will try and just boil it down to the bare essentials. I will say off the bat, the number of situations where this is actually an advantage, especially in GameMaker, are not too many. So to start with, because GameMaker is slow most of the time when you're making a 3D game in GameMaker, the bottleneck is, like, actually running the GML to do the vertex submits that actually draw the scene. And if you just do that twice, you're just taking twice as long to draw the scene, and whatever's happening on the GPU is the bottleneck. So already, that's going to rule out this as being a thing that most GameMaker games want to really care about. At least in deferred rendering, actually drawing the, like stacking the frame buffer surfaces and actually drawing the deferred pass is fairly cheap in terms of GML. So this is only really going to be useful in GameMaker if you're making a game where everything in your game is, or at least almost everything in your game is combined into a single vertex buffer, like this Hyrule Circuit model from Mario Kart 8 that I've loaded in. And also, when I say that you need a really complicated fragment shader for the benefits to really outweigh the cost of rendering the scene twice, I mean you really need a complicated fragment shader. So I'm going to show some examples of this. This is the basic 3D stuff shader that I'm drawing the scene with is right now taking 8 point lights and calculating 8 point lights on this this big whole Mario Kart 8 Hyrule Circuit, and I'm going to show how that scales at different at different levels with different numbers of lights in the fragment shader. So to get started, we are going to want to do something, and I'm going to actually comment out rendering the race course like for regular. I'm going to delete the shader. This is depth prepass because that was what I was testing this with, and I forgot to remove it before we got started. It's actually really simple, so let me go and recreate that shader real fast. So let's say sht_depth prepass. We can just completely ignore everything that's in the vertex shader. In the fragment shader, I'm going to do nothing but say gl_frag color is going to equal vec4 of all ones. So we're just going to render a pure white scene. It would not be a terrible idea to do alpha testing, so I guess in addition to that, I will say if the sampled texture.alpha is less than 0.5, then we can discard. This is pretty basic alpha testing. I'm sure you've seen this before at some point along your GameMaker adventures. Alright, I guess that's it for the shader here, for the prepass shader. I'm just going to strip out some of the unnecessary stuff that we don't really need. So we just need position. We don't need the color. We're not dealing with color right now. No point having that in the pre-pass shader if we don't need it. And I am going to at the top here, after we set the camera projection, after we set Z test and right, after we draw clear and like set the culling direction, I am going to shader set SHD depth pre-pass. I'm also going to just like stick a little title in the comment there, depth pre-pass, and I'm also going to label the regular lighting pass at the bottom there. So when we do this, we can say just render the race course. Don't worry too much about how this works. This is basically just a loop over every vertex buffer that was loaded from the Mario Kart course file and just draws it in one shot. I want to say there's like 20 or 30 individual vertex buffers in this Hyrule circuit. So it's not like we're drawing the entire race course in one single shot, but it's also, it's not too crazy. It's just 20 or 30 vertex buffers is nothing. So let's run this, and we're going to see... You can probably guess what we're going to see, honestly. But once this actually loads, we're going to see the entire race course drawn in white. And that might not look that useful, but we're also, more importantly, writing depth information to the depth buffer. We don't need to access the depth buffer ourselves. Depth buffer access is something that we got in GameMaker a couple of months ago, but it's not really going to be important here. The important thing is that we're just drawing the scene in our depth pre-pass. We're saving the depth information to the built-in depth buffer. And then when we render the scene in the lighting pass, we are going to want a way to only actually draw fragments. As I said at the beginning of the video, we're only going to want to draw fragments that are actually in the front of the depth buffer. So if we have, like, for example, the hills in the background drawn first, and then if we have the giant, like, Hyrule Castle being drawn on top of that, we don't want to have to do anything to any of the fragments in the hills in the background that were covered up by the castle. We don't want to have to run any lighting calculations on them. We don't have to want to do anything else that you might do in the fragment shader. And the way that we can do that is that, and I don't think I've ever talked about this function before. It might have been in the Z fighting video, but GameMaker has a little function built into it that is GPU set Z function, and it takes an argument which is going to be the compare func. The compare function. That sounds really weird to say out loud. And there's a couple different compare functions. There's compare function less, compare function equal, always greater, greater equal, less equal, never, or not equal. Basically the numerical comparison operators in, like, GameMaker macro form. So by default, the compare function is going to be less than or equal. So when you draw something in 3D and you have depth testing and depth writing turned on, you will draw whatever it is that you're drawing. If the depth of the thing that you're drawing is less than or equal to the depth of whatever's already in the depth buffer. So if you wanted to, you could use any of the other compare functions for this. If you wanted to turn the entire world inside out, and I don't know why you would, you could use the compare function, compare func underscore greater. I'm sure there's a weird and fascinating use for that somewhere in computer graphics, I just don't know what it is. In our case, since we want to only actually draw stuff, only actually keep fragments that are, as I said, in the front of the depth buffer, or maybe in more, like, technical terms, fragments that have the same depth as whatever is set to the depth buffer, we can use the compare function equals for this. And now if we were to draw the scene again, we will essentially be masking out all of the pixels in the scene that are not stored in the depth buffer. And also, before I run this, I'm going to want to... apparently, I forgot to get rid of the mip mapping function from earlier, because that was the project that I cloned to get this one. Let's set this back to less equal at the end, so that it's reset for the next frame that we try to draw this in. So let's run this now. And if everything goes as correctly, you'll notice that the scene should look pretty much exactly as it did before, except that performance is actually quite a lot lower. So I talked about this. I said that this is only really going to prove to be an advantage if you have a very complicated scene with a very complicated shader. And what we've got here doesn't really qualify. I actually had to push this, like, really far when I was testing this earlier to get a scene where this actually showed better performance than just doing it the normal way. Before I make any more changes to the code, let me say var do depth test equals keyboard check VK. What key do I want to put this on? Let's put this on like the control key or something, because I don't think I'm using that for anything here. So we can hit the control key to do the depth prepass to enable and disable the depth prepass. Like if that condition is met, you're going to set the prepass shader and draw the course like that, and then in the regular pass, we're only going to want to set the compare function if you're doing the depth test, because otherwise it's just going to not draw anything because the screen has been cleared to an empty depth buffer. And I think also in the draw GUI event, I can say if we'll just draw on the UI whether or not we're using the depth prepass, and we can look at this and we can compare the performance directly. So I'm gonna find a let's say a nice little vista in the scene to look at things from, probably around here, looking at the castle. All right, the texture on that, like the starting banner on the racetrack, is a little funny because it came in using the wrong texture for some reason, but who cares? We're getting about 840 FPS with an uncapped frame rate here, and if I hit the control key and enable the depth prepass, we're going to drop that down to about 600, which is definitely not how you usually want optimizations to go.
Hey.
So just to be clear, what we're doing here is a GPU bound. We're not being bottlenecked by the GameMaker code. As I said, when we draw the course inside this render method, it's just going to go in a loop and submit like 30 vertex buffers at once, which is pretty much nothing. So if you want to stop the video here and try and construct a scenario where doing the depth prepass here will actually be a performance benefit, feel free to go ahead and try to do that. I am just going to jump ahead and bump up the light count in the shader from 8 to 256, and like, this is something you should never do, right? If you need 256 lights in a scene, then you're doing something a little bit extraordinary. You should probably think about an alternative way to do it. At this point, you're like starting to run up against the limit of how much uniform data you can send to a shader at once, but we're going to pretend that that's not an issue, at least not for this demo here. I'm going to bump up the light count, and I've arranged these lights in a grid, like just a regular grid over the scene, so that we can actually like make sense of what we're looking at. Let's squeeze them a little closer together too while we're at it, and I'll just move some of them randomly higher in the air so that possibly the top of the castle, or at least higher on the sides of the castle, can actually be lit. So we've now got what is this going to be, like 32 times more lights in our scene than we had before. If I were to just draw the scene like regular, where was I? I think I was overlooking the starting block on the race course, like around here last time. We're going to be getting about 90 FPS when we do this with 200 and something lights in the scene. If I hit the control key, this is going to be bumped up from 90 something to 160 something, 170 something. So in this case, we've got, what's that going to be, about an 80% performance boost by using the depth prepass here when we're drawing a scene that's this heavy on the lighting information. If you want to see what the scene like this looks like from a zoomed out view, this is pretty much it. This is a lot of lights. Not all of them are actually like contributing to the lighting on the scene. Maybe I should not put some of them as high in the air as they are, because maybe they're just too high. Let's lower that back down to 80 like I had in the test project. I think 96 is a little better actually, because you can actually like see from here the lighter and darker patches, and there is indeed a little bit more light on the castle when we do it like this. Anyway, so we can now see the an actual tangible benefit of using a depth prepass. This will also vary from like different parts of the scene from one to another depending on how much is actually on screen. So if I were to look at, for example, this part of the castle, we'll be going from like 65 to like 130, which is almost a doubling of the frame rate. But if I were to look at, for example, something maybe like more off screen over in this direction, we're going to be going from 280 FPS without to, and I suspect it'll actually go down here, 260 with, yeah. So that's the performance boost you can expect to get from a depth prepass. I probably wouldn't recommend actually doing it in GameMaker because, like, the number of situations where it's actually a benefit are so few and far between. But I thought it was an interesting idea. There's a couple of other lighting optimizations that you can do, and specifically with deferred renderers that I like to talk about, such as cutting out lights that are only, like, lighting up, like, a portion of the scene. Like, if a light is only having its effect cast on, like, one half of the scene, you don't need to calculate it for the whole scene. And deferred renderer makes that somewhat easy because you can do the deferred pass in, like, tiles. But we can take on that later. For now, my name is Michael. I like wizards and dragons and making games. I like to post videos on the weird stuff you can do in GameMaker, as I'm sure you can see here. So if any of this weird 3D stuff appeals to you, feel free to subscribe. I also do make normal videos once in a while. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. You should all go check out Wizarducks and the Lost Hat, which is the game that I like to work on when I'm not doing YouTube stuff. Link to that can be found down below. I hope you all found this interesting, and I will see you all later. Special thanks to Zenjamin, VitroV, Squarecrow, Spy Die Games, Manta Ray, GameMaker, Edward Holt, and DJ Gibbles for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.